Annis, are you there?
Yeah.
Okay, can you tell me, to start out, can you tell me the three states of matter that we talked about last week? Three states of matter.
Solid, solid, liquid, and gas.
Solid, liquid, and gas. Very nice. Solid. Woof, that's solid, sure one. Liquid. There we go. And gas. All right, so this first part, I'm just letting you guys know it's gonna be the same thing we did at the end of class. So if you don't wanna write yet, you may not have to unless you see something that you're missing in your notes, okay? So remember we talked about we were talking about physical changes, right? So one of the things I want you to know is that phase changes, if we didn't already say this, phase changes are physical changes. So pH, that's how you remember it, okay? So they are not chemical changes, which we'll talk about on Wednesday. But basically, or maybe today if we have time, but basically, sometimes we get confused and we think a phase change is physical because we think a phase change is chemical because it looks like we made something new, but we really didn't. All right. So we had 6 phase changes. Brandon, can you give me one of the phase changes that we had?
Freezing.
Freezing. Very nice. So we had freezing. Cameron, can you give me one after that? What's the opposite of freezing if you know? If I leave a chocolate bar in my car, Cameron, what do you think is going to happen to it if it's like July?
Oh no.
Melt.
Very nice. It's going to melt. So melting. All right. And if we talk about these, remember in all of this, it's just a switch between solid, liquid, and gas. So is it going from a solid to a liquid, or a liquid to a solid, or a solid to a gas, or a gas to a solid, or a liquid to a gas, or a gas to a liquid? That's all phase changes are, okay? So if we're freezing something, okay, what are we starting out as and what are we changing to? This is anybody.
Liquid, solid.
Very nice. We're starting at a liquid and we're changing to a solid. And then Cameron was telling us that melting is the opposite. So on this one, we're starting as a liquid and we're changing, sorry, we're starting as a solid and we're changing to a liquid. All right. And then we had the one where, remember, if I were to show you, let me stop sharing for a second so you guys can see me, okay? So if you look at my bottle, there's all this water on the side of it. Anybody remember what that water was called?
Condensation.
Condensation.
Very nice, condensation, okay? So condensation is another phase change. And I'm gonna give you another example of it. When you wake up in the morning, okay, and you get ready to leave your house, sometimes if you walk outside and you happen to walk in the grass, your shoes get wet, but it didn't rain the night before. What's that water on the grass called?
Dew.
Dew, very nice. Dew is also an example of condensation, okay? So from this one, we're going from a gas to a liquid. Okay, all right. Who remembers which one was the opposite of condensation? One went from a liquid to a gas. What was that called?
Sublimation.
Going from a liquid to a gas?
Boiling point.
Boiling point.
Yes, boiling. So I want to make a note here, okay? There's a couple of different things we're gonna call it, okay? So the first one I'm gonna write, if you didn't have this one written down, write this one down in 2. We're gonna call it vaporization. Now you don't have to erase if you have boiling, okay? But I'm gonna tell you, we have 2 different types of vaporization. One is, just as you guys said, boiling. Okay, so we usually have something, it gets hot and then it turns into a gas. But there's another one, like for instance, if I had a beaker of water left on my desk and I left it here for 3 weeks and I came back and it was gone. What happened to it?
It turned into a gas.
It did. What do we call that when it just looks like it magically disappeared? I didn't heat it up. It just kind of disappeared over time. What's that called?
The sublimation point.
Nope, not quite. Anybody else remember? So it looks,
Evaporation.
wait, what'd you say?
Evaporation.
Evaporation, very nice. It looks like vaporization, but it's a little bit different. It is evaporation, okay? All right. So those are all really kind of the same. Vaporization is kind of like the heading, and then boiling is a type of vaporization. Evaporation is a type of vaporization. The only difference is where the phase change is taking place. But I just want you to know both of those. Anywho, though, either way, it is going from a liquid to a gas. All right, Annis, I heard you saying this one a lot. What's the one you were kept saying for me?
Sublimation point.
Sublimation, very nice. All right, sublimation. All right, sublimation. Now, so far we've gone from a liquid to a solid, solid to a liquid, gas to a liquid, liquid to a gas. So what are we missing? Now we need to go from what to what? There's only two options left.
Solid to gas.
Solid to gas and or gas to solid. Very nice. So sublimation is going to be from a solid to a gas. And like I said, we should have had most of these already. And then, oops, not liquid. Sorry. Undo, 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 undo. And then this one would be a gas to a solid. Okay, and that one is called, anybody remember the name of this, Joe? Did you have a name from a gas to a solid? Did you have a name for that?
Was that one deposition?
Yes, it is. Very
A
nice.
name for it?
Yes, very nice. Very helped you out. It's deposition. All right. So here's the weird thing. It's kind of hard to, everyone knows what freezing is, right? We all know what melting is. Condensation, okay, we got some examples, dew on the grass or the water on the side of your cup. We know what boiling is or evaporation. Sublimation and deposition are kind of weird, okay? So those are kind of weird, right? It's like, how do you go from a solid straight to a gas and you never turn into a liquid? Or how do you go from a gas straight to a solid and you never turn into liquid? So I want to show you two quick videos just so you have an idea that it can happen. And one of them you may not be familiar with, but the other one you will be. Or I think most of you will be, okay? So let me share my screen. There's no sound, but I want you to look at this. Anybody know what that stuff is?
Dry ice.
Dry ice. Okay, so does anybody know what dry ice is made of?
Isn't like something like carbonitrate?
Not quite, but you're in the right realm of chemistry. It's something that actually we are exposed to every day. It's something that we happen to breathe out.
Carbon dioxide.
Very nice, carbon dioxide. So dry ice is carbon dioxide, but really, 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 really cold. Like realistically, this man should have on gloves, okay? Because if he touches that stuff, it's gonna burn his finger. That's how cold it is, okay? So luckily he has it in a basket, but realistically he should have on some gloves. So let's look at this. So if you look, he's whacking it to pieces. This is very unsafe, by the way. All right, so he's gonna put some water in the sink here. It's not hot water, it's just right there in the center, so it's just regular water. Now, if you look, even before he puts it in the sink, what do you notice about the dry ice?
You can see the mist of it.
Yeah, and it's not really a mist. Guess what it actually is? It's like smoke, right? Because a mist would be wet, but you can't even feel it. So it is already sublimating, which means it is already turning from a solid to a gas. Okay, so let's see what happens when he puts in the water. Now it's like lots and lots and lots of smoke. So this is all the stuff that we see if you go to a concert or some type of scary house like the haunted houses. This is all the stuff that they use. Okay, so that is dry ice all over his kitchen. It is not, if you were to touch it, you wouldn't feel anything because it's a gas. It's a gas. You can't even hold it. Okay. Now, here's the interesting thing about dry ice. Okay, it is carbon dioxide. We're used to carbon dioxide being a gas. Okay, this is really, really cold. When we think about heating something up, heat is very relative. Okay, so what is hot to us may not be hot to other things. So in this case, that carbon dioxide, when it's turning into a gas, what it actually is doing is boiling. Okay, it's actually boiling, but in our minds, we're like, it's not even hot. Well, it's not hot to us, but to that carbon dioxide that's super cold, it is burning up, and that's why it turns straight to a gas. Okay, so that is one video. So that is sublimation. Okay, and then I want to show you this one. This is going to be sublimation, and we're going to get to see deposition as well. Okay, so on this one, iodine, okay, is like these little, in its natural state at room temperature. Okay, so like the temperature in your house, it's a solid. Okay, so they're going to put some iodine into this beaker. That beaker is sitting on top of a hot plate, so they're heating it up right now. Okay, notice when it starts to heat up, so there's a hot plate right here. Okay, it's heating up. It never turns into a liquid. It turns straight into a gas. It is subliming. Okay, now they put this flask with ice into it. Okay, to trap that gas inside of there. One, they're trapping the gas. Okay, and the second thing they're doing is, because there's ice in this beaker up here, it is going to cool down that gas. Okay, well, once we cool down that gas, look what it turns back into. It turns into a solid. So it turns into these little crystals, and you can see them forming on the bottom of that flask. Okay, so now they have these nice crystals. Okay, no liquid anywhere, just solid to gas or gas to a solid. Okay, iodine, by the way, is very dangerous. We don't use it in class a lot because we have to use a fume hood because the fumes are toxic. Okay, all right. So now let's go back to our whiteboard notes. Okay, so now we have a couple of different examples, all right, of the 6 phase changes. Now I'm going to talk about what's actually happening. Okay, so I'm going to change screens. All right, now everybody's taking notes because we got some new stuff going on. Okay, all right. So you're going to make kind of like a triangle of things. So we're going to put solid at the top. It really doesn't matter which one you put at the top. Solid, I'm going to put liquid down here in this corner. And then I'm going to come over here and put gas. Okay, solid, liquid, gas. And what we're going to do is we're going to talk about what happens when a solid turns into a liquid, and what happens when a liquid turns into a gas, and what happens when a gas turns into a solid. Okay. After we talk about that, we are then going to talk about what happens when going the other way. So now we're going to talk about going from a liquid to a solid to a gas, and a gas to a liquid. Okay, so get that drawn out on your paper. I'll give you a second. All right, so if you got that drawn out on your paper, Darshina, what did we say it was called when you went from a solid to a liquid? What did we say that was called? What phase change was that called? From a solid to a liquid?
Melting point.
Melting, yes. Darshina, I'm gonna come to you again in a second. Darshina, you tell me what it's called if you go the other way. What about from a liquid to a solid, Darshina?
Freezing.
Freezing, very nice, okay? All right, so now I want you guys to think about this for just a second, all right? We're talking about melting, okay? We're talking about melting. I left a chocolate candy bar, a Snickers, my favorite candy bar, okay, in the car in July. Why did my candy bar melt? Somebody tell me why it melted.
Because it was exposed to heat.
It was exposed to heat. Very nice. So when I looked at my candy bar, it went from a solid to liquid because there was heat added to that candy bar. Okay. It's still chocolate. I may have to lick it off the wrapper. It's melted. It's a liquid now, but it's still chocolate. Okay. Which is what makes it a physical change. Okay. Physical changes means you still have the same stuff you started with. It just looks different. Okay. Now, if we're thinking about this in terms of heat only, okay, because realistically, we haven't talked about this yet, but realistically, there is no such thing as cold. I know some of you guys are like, all right, how does she get a job? Because that is definitely not true. But cold is actually, it's not necessarily cold, it's just really the absence of heat. Heat exists, but cold is really just the absence of heat, okay? So when we're freezing stuff, what is really happening? What are we doing?
You're zapping the heat away. Basically, you're slowing down the molecules in an object.
Ooh, Dominic, yes. All right, fantastic. We are zapping the heat away or we are losing heat. And he talked about some other stuff with molecules, which is true, but we'll talk about that later. We're not quite there yet.
Absolute zero.
Okay. Showing off. Very nice. We will talk about absolute zero as well. All right, so let's think about all our other phase changes, okay? And what is happening in heat? Because realistically, that's all that's happening when we do a phase change. It's like, am I adding heat or am I taking away heat? I'm either adding some heat or I'm taking away some heat. I'm adding heat or I'm taking away some heat. That's all that I'm doing. So, John, are you there? Yes. Okay, I can see your chat. Can you tell me if I go from a liquid to gas, and if you can unmute, that'd be better, but if you can't, I can kind of see the chat. If you go from a liquid to gas, can you remind us what that was called? Going from a liquid to a gas. Liquid to a gas. Let's see. Evaporation, very nice. All right, so we're gonna say, and you can say it however you want. I'm gonna put vaporization, but remember it's vaporization or boiling or evaporation, as John said in the chat. Okay, vaporization. All right, and then Irving, are you there? You still in here? Irving, you there?
Yeah.
Fantastic. What about going from a gas to a liquid? Do you remember what that one was called? Gas to a liquid. So that's like when I have the water on the side of my glass.
No, honestly, I don't remember.
Okay. Sid, do you remember what it's called? Going from a gas to a liquid?
Condensation.
It is condensation. Thank you very much. All right, so I want you guys to think about it. Don't say the answer out loud yet. One of these, we are adding heat. The other one, we are taking away. See if you can figure out which one it is. Don't say it out loud just yet, though. Okay. All right, Fisher, you want to take a guess at which one do you think is adding heat? Which one do you think is adding heat, Fisher?
Wait, what did you say is adding heat though?
Which one is adding heat? Is vaporization adding heat or is condensation adding heat?
Vaporization.
I agree with you wholeheartedly. This one is definitely the one that is adding heat. All right, so that means this one must be losing heat, okay? And now let me write this to the side that when I say minus heat, that means losing heat. Okay, and then this is plus heat is adding. Okay, all right. So now we've got two more left. Jamie, are you there? All right, Isaiah, are you there?
Yeah.
Okay, can you tell me, you can tell me either one, either solid to gas or gas to solid. Tell me the name of it, whichever one you want to tell me.
What?
Yes, I can't, sorry, what did you say?
Wait, what are you talking about? Oh, wait, sublimation?
Sublimation, which one? Is that gas to solid or solid to gas is sublimation?
Solid gas.
Solid to gas, very nice, all right. So solid to gas is sublimation, let me see, that's this one. So sublimation. Very nice. And then, Joe, what's the other one called? So gas to solid.
Starts with the
Starts with a what? Say again.
I don't know.
You just wrote it down, or you should have it in your notes. Do you know what it starts?
I have no clue. I was thinking of a different word.
Wait, what'd you say? No, what'd you say? I just can't hear you.
Yeah, it starts with the D.
Yeah, starts with a D. Looks like, what word does it look?
Right?
Tell me what it look like then. What does it look like? It sounds like. Looks like this word, right? Looks like deposit. It's called, and a lot of times.
Is it deep? I don't know.
You're right. It looks weird when you say it, but it's deposition. Okay, deposition. So it looks like deposit. So if somebody said deposition, that's fine, but it's deposition, all right? So you guys take like 5, 10 seconds, figure out which one you think is gaining heat, which one you think is losing heat, okay? Take a couple of seconds. All right, Faith, are you there?
Yes.
Okay, do you want to take a guess at which one of these is gaining heat? Do you think sublimation is gaining heat or deposition? And it's just a guess. So do you think for me to go from a solid to a gas, I have to gain heat? Or if I go from a gas to a solid, do I have to gain heat? Which way?
You go from a gas to a solid.
Gas to a solid. So I have to heat up the gas for it to turn into a solid, or do I heat up a solid for it to turn into a gas?
No, you heat up the solid to it turn to a gas.
Very nice. So sublimation is the one where you gain heat. And then this is the one where you lose heat. Very good. So when we are talking about phase changes, okay, we have 3 states of matter, solid, liquid, gas. You know, there's some substates and there's plasma, of course, but for the purposes of this class, 3 states of matter, okay? So 3 states of matter, solid, liquid, gas, okay? And for us to change in between them, we are either gaining heat or we're losing heat, okay? So for me to, if you really think about it, think about what we said. How, Eric, what are the particles like in a solid?
A solid, the particles are really like compact and really close to each other, and they don't have space to move, that much space to move.
Very nice, good job. So think about this, guys. If you have a solid and everything's super close together, and then you heat it up, does it make sense that those particles would kind of start to get a little bit more room? They would start to flow, which is what a liquid does, okay? And then if I heat those particles up even more, we can break, we haven't talked about this yet, but you're gonna break some bonds in between those particles, and they're gonna get even more spaced out because I added some heat, and then they turn into a gas, okay? So that's exactly what's happening, okay? And then it's the opposite to going the other way, right? If I'm at a gas, okay, and I cool it off, those particles that are really spaced out, they start slowing down and they turn into a liquid, okay? And then if I cool them down even more, take away heat, they turn into a solid. All right, so there was one more thing I wanted to say, or two more things I wanted to say. Yes, so make sure you know when and it's not going to be on the quiz today, but make sure you understand phase changes in terms of losing heat and gaining heat, okay? So realistically, we're just kind of breaking the bonds in between those particles that are stuck together, okay? So it's allowing them to either move further apart or get closer together. The other thing I was going to say about condensation, okay, if you think about it, this should make sense that condensation is losing heat. When we talked about there being dew on the grass, who's seen dew on the grass in the middle of the afternoon? Nobody, because the coldest part of the day is usually in the morning or late at night, and that's when you see dew on the grass. If I have a drink and there's no ice in it or it's hot, you don't get condensation on the side of your glass. It has to be cold. So that's why condensation has to do with when you're losing heat, okay? All right, and realistically, just to kind of tell you a little bit about that before we go into this quiz, all right? What's happening is, if I have this, I pull this out of the refrigerator, okay? What's happening is there's air all around this bottle, okay? When this air hits the bottle and this bottle is cold, that air cools down, and there's water, always water in the air. So it cools down and now it's stuck on the side of your glass. And that's why you have water on the side of your glass. All right, so any questions about phase changes today? Okay, I want to write one more thing and that's it. There's one more that's kind of tricky, okay? It's not a phase change, but people get tricked up on it. It is dissolving. I'm going to put it right here, okay? All right, dissolving is a physical change. It kind of looks weird because you want to think it's chemical because it looks like you've made something new, but realistically, okay, if I put salt and water and I stir it and the salt quote unquote disappears or dissolves, I've just made salt water. Does it still, if I drink that water, is it going to be salty? Yes or no?
Can you repeat that?
If I put salt into water and I stir it and I drink it, will that water be salty?
I
Yeah.
hope it is.
It will be salty, okay? I have not chemically changed anything about it. So on Wednesday, we're going to talk about chemical changes where if you do something it's going to make something new. Like we talked about the other day, if I burn a piece of paper, I get smoke and I get ashes. I get a bunch of new stuff. Okay, so dissolving is a chemical, physical change. All right, any questions on this? All right, here we go. So you have a quiz. You're going to have about 10 minutes to work on it. And I think that will be plenty of time. All right, so if you go to, let's see. Let me go to courses. Are you guys still seeing my screen? Good, okay. So if you come in here, you can go one of two ways. You can go down and you can go into, it's not the folder that says phase changes. It's going to be the one that says states of matter and physical chemical. Or you can come here and click homework for next class. You got to kind of slide over. I don't know why it's right here. Click homework for next class. So I am in the folder that says states of matter, physical and chemical properties. So it looks like it's from last week, okay? Scroll down, physical chemical properties. It is a homework quiz. It is due today. You have 10 minutes to do it. Most people have finished the quiz already, okay? I would do breakout rooms, but I'm just gonna leave everybody up. And then if you have a question, you can just unmute and ask your question because chances are a lot of other people have it, all right? Any questions about what you need to be doing right now? We're doing a physical chemical properties quiz that is due today. It shouldn't take you, I wouldn't think it would take you, if you move really, 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 really slow, it might take you 20, 30 minutes. I don't think it'll take you that long, okay? All right, that's what we're working on. I'm gonna stop sharing. And I will be right here if you need anything. I'm gonna mute myself. I'm gonna make sure everybody's working on it though.